In this video, we are going to talk about an alternative to net present value called internal rate of return. Internal rate of return may be the most commonly used alternative to net present value. Internal rate of return corresponds to the return an investor gets overall in the life of a project. It is the interest rate that equates the present value of future cash flows to the cost of the investment. Or it is the interest rate that gives a net present value of zero. The idea here is that investors want a return over and above the required return. One way to measure the return over the life of a project is with the internal rate of return, and if it's higher than the return that they require, you want to invest in that project, and if not, you don't. Then if you rank order projects, it's in return of highest to lowest return for the investors. Now, calculating internal rate of return is fairly easy for single cash flows, for annuities and perpetuities. It's challenging, although your financial calculator makes it easy, for variable future cash flows, like our projects B and C. For A, it's actually simply a matter of determining the return that equates the single future cash flow with a value today. So the internal rate of return for A is whatever interest rate solves the equation present value of the cash flow in a year is equal to the cost of the investment. Well, cross multiply and subtract 1 from both sides. So the internal rate of return to A is 0. You get no return. You get back exactly what you invested. So that one is easy. And it's pretty easy for annuities. It's pretty easy for perpetuities. What's more challenging is when you have an uneven set of future cash flows. So you need to find the return, for example, for B, that equates $1,000 in a year, $1,000 in 2 years, $4,000 in 3 years, $1,000 in 4 years, $1,000 in 5 years to the investment. The trouble is you cannot solve this algebraically, but that is exactly what your financial calculator is designed to do. What you do is you enter the cash flows for the project, in this case $2,000 cost, negative today, 1,000, 1,000, 4,000, 1,000, 1,000, and then to get the answer, you just press the IRR and compute. Now your calculator finds the internal rate of return, the return on investment, that is closest to 0. So in this case, it's 67.77. For C, the only thing we change is the cash flow in year 3 and the cost. Sorry, that's 3. So let's see, cash flows, a $3,000 cost, 1,000, 1,000, 5,500. Internal rate of return compute, 51.35. Okay. In essence, what you can do is you can take a look at varying the discount rate until you hit the point where the net present value is 0. And the point that the net present value profile, it's called, crosses the 0 line is the internal rate of return of a project. This is an example of sensitivity analysis that we'll talk about a lot in class. So, internal rate of return for a normal project, one with negative cash flows at the beginning followed by positive cash flows. The accept-reject decisions are always the same as net present value. It also weights it per dollar invested, so it helps with capital rationing. But just like profitability index, it is biased towards small projects when projects are mutually exclusive. So how do you fix that? The same way as you do for profitability index, you find the internal rate of return of the incremental project. So the internal rate of return for B and C are both higher than the required return. Let's go back and see. The internal rates of return are 51 and 67%. The question is it worth the additional $1 million to get $1.5 million in 3 years, taking the incremental project, the difference between C and B? Well, the answer is yes. We need to find the interest rate that equates the present value of the incremental cash flow with the additional investment we need to make. I'll cross multiply. Then what we'll do is we'll take the third root. Then all we need to do is subtract 1 from both sides. And that's the interest rate. You could also do it with the cash flow buttons on your calculator, but let's go ahead and do it this way. 1,500 divided by 1,000 to the power of, in parentheses, 1/3 minus 1, 14.47%. So it's not as good as either of the individual projects, but the additional investment of $1 million gets you more than the return that you require on that additional $1 million. So it's worthwhile to increase your investment to go for the larger project if they're mutually exclusive. This is essentially exactly the same fix as incremental profitability index. There's a variety of other issues with internal rate of return that we will talk about in class.